Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to Dr. Ruzaini bin Hashim and my fellow friends. Today, I want to make you a short presentation about our PBL project. Our PBL project is Car Portable Vacuum. First, let me introduce our group member. First, that's me, Fairumi Rosli, and my number is Aina Shahira binti Mansur. We group quotes is if the plan doesn't work, change the plan but never the goal. Before going too far, we must know the history of vacuum. According to etymology, the word vacuum comes from Latin and empty space, void, noun use of neuter of vacuus, meaning empty. Vacuum is one of the few words in the English language that contain two consecutive letter U. And history. Many Greek philosophers, physics and Islamic scholars differed on their study and opinion. Among them, Plato, the hero of Alexandria, Al-Farabi, Ibn al-Hajjaj, Abu Rayyan al-Biruni, and Roger Bacon. And 1654, Otto von Gutenberg invented the first vacuum pump, conducted his famous Magdeburg hemisphere experiment, showing that, owing to hemisphere pressure outside the hemisphere, steam of houses could not spread to hemisphere from which the air had been partially evicted. And why use car portable vacuum? Car portable vacuum cleaner are portable cleaning machines that use vacuum suction for cleaning purpose. Car portable vacuum cleaner can lift the dust and other debris out of carpet and off surface from the windshield. Next slide is problem statement. Problem statement is car agreed to drive, but maintaining them can be a bit of a problem for some people out there. Car maintenance not only include maintaining the engine, but also cleaning it just as important. A car portable vacuum cleaner is the best choice for this. They always come to the rescue when trying to remove dirt, hair and food waste garbage from the windshield. But with continued mission and function, one may face the problem of a car vacuum cleaner, which can eventually lead to its fail. Speed on a vacuum is a problem that is often heard from users because speed on a vacuum affects the amount of suction. We have three objectives in this PBL project. First, to understand the principal speed of car portable vacuum. Second, to exchange problem-solving capability for device coding and hardware deployment. And third, to determine the speed of the car portable vacuum by using visual simulator. Before we start the coding and simulator, we do the Philas table. Philas table meaning is F for fact, I for idea, L for learning issue, A for action plan, and S for solution. Fact: most of the person have car, have wastes or dust inside car. Ideas: we use Easy68K microprocessor to make a coding for control speed of car portable vacuum. We use 7 segment switch to control the speed of car portable vacuum. We use Easy68K microprocessor and relate the connection of component and hardware using suitable coding. Learning issue: what is car portable vacuum? What are the objective car portable vacuum? Action plan: group decision, brainstorming, design the project and run the hardware simulation, learn assembly language, design program, execute and simulate the program using Easy68K to create a problem coding. And lastly is solution: control the speed of car portable vacuum in 3 speed by creating a coding using Easy68K. Next, my friend Aina Shahira turn to show coding and simulator.
Okay, I will explain about our program coding. There is car portable vacuum using Easy68K. Firstly, we put start as first instruction of the program. Secondly, we go to declaration part. This part is where we declare all of the hardware we use in our program, for example switch, LED, and all 7 segments. We use EQU command to declare all the hardware into memory. Next, we go to initial condition. For example, we use ORG $1000. That means program will start at memory 1000, and move.b immediate hexa 1 to DO means initial condition is assigned to LED and stored in DO. Same goes to the others. We assign which is first switch, second switch, third switch, fourth switch, and fifth switch. Next, we go to main loop and decision making part. This is our main body of program. Here we have move.b DO LED, which means value in DO will move into LED. cmp.b switch T1 BEQ startup, which means if the switch value is high, then it will jump to startup subroutine. This is our loop and we repeat it. Then we use BRA main, which means the command will loop continuously. Then we go to startup subroutine. This startup subroutine is data to display a specific pattern to 7 segments, and we put BRA main, so all command here will loop to our main loopback. Then we go to speed 1 subroutine. In speed 1 we have rol.b immediate 1 DO, which means rotate the operand to the left. Move.b DO LED, which means value of DO will move into LED. BSR fast means it will jump to fast subroutine. And here is a data that display the specific pattern of 7 segments. Same goes to speed 2 and for speed 3 subroutine. Finally, we go to stop subroutine, which is blinking LED part. Above here, command for blinking LED part. When we execute this command, then LED will blinking at the display. Below here is data to display a specific pattern to 7 segment display. Then we go to delay subroutine part, which means delay program which we use for data to manipulate for speed. For example, speed 0, move.l immediate $10,000 DO. Here is determine our speed, which mean if the value is lower, mean our speed is fastest. Then we have $1000, which mean end of the program. Then for simulation, we run the program, then make sure there is no warning and error, then we execute. So it will appear this display, and we go to view hardware. This is the hardware display. We click the interrupt button. So when we click 0 button, the hello word will display on the LED. Then if we click 1, the speed 1 is running. If we click 2, the speed 2 is running. When we click 3, the speed 3 is running. And we click 4, the stop will be displayed and LED will blinking. That's all.